multiply by 2 on each side to get 14 minus 8x squared equals mv squared. Okay. I'm going to stop right here. Normally you'd probably want to go ahead one step further and divide it from m from each side, and then you'd have your velocity, and then you may think, okay, we'll differentiate your velocity with respect to time. But if you do that, then you're going to have to use the quotient rule. So this little shortcut here is going to allow me to skip using the quotient rule, and I can just differentiate just regularly, okay? So I have one side that's in terms of x and one side that's in terms of v. What that means is if I were to take the derivative of x with respect to time, so take the time derivative of the left side, then I can differentiate this x, and what I'll end up with is a velocity on the left side and a position. And then over here, if I take the dv dt, time derivative on the right side, with respect to velocity, then I'm going to get my acceleration, right? Just dx over dt equals v, and dv over dt equals a. So let's do that on the next page. I told you 14 minus 8x squared dx dt equals mv squared dv dt. Okay. When I take the derivative, my very first step, if you don't remember, is multiply by your coefficient, the exponent by the coefficient to get negative 16, and then subtract 1 from your exponent, negative 16x. When we have a whole number, that just goes away, because if you subtract 1 from the exponent, remember our exponent here is going to be 0, is 1. So if we take 1 away from 0, it's 0, and then that goes away. So we have 16x dx dt equals 2mv, differentiating that, dv dt. dx dt, I said, is a v, 16x v, and then dv dt we said was a, so this is 2mva, and we're looking for a, so let's go ahead and divide by 2mv from each side. That goes away, that goes away, that goes away, and of course that. So we're left with negative 8x over m equals a. X is 0.6 times 8 divided by m, which is 3, equals a. 8 times 6 is 48, divided by 3, 48 divided by 3 equals a, and that's going to be like 1.6. So a equals 1.6 meters per second squared. If you do not write your units, you will lose out on very important, easy points, right? You put in the work this year, you know your units, just go ahead and write them in there. You don't have to have your units right here. You don't have to say this 8, whatever this was, so let's say it was joules or whatever. You don't have to have that in there. But at the very end, make sure your units are there and correct. All right, going forward, we need to go to E. E is the graph. Well, we know the, let's see. On the axis below, sketch the graphs of the object's position, x versus time, and kinetic energy versus time. Assume that x equals 0 and t equals 0. So that means we're going to start from the origin right there, okay? We know that we're getting to negative 0.5 at some point, and we know we're getting to positive x at some point. So if you have this, you may or may not be able to see that. That's a little bit better drawn. At the positive, it's going to reach a maximum, and down here it's going to reach a maximum in the opposite direction, for sure. And then it's going to return and come back. How do we know it's going to return? Because there's potential energy involved. We don't know that it's spring potential energy. It probably is 1/2 kx squared, right? That's our spring potential energy, 1/2 kx squared, and we're given u as a function of x squared. So 1/2 of k is probably 4, so k is probably 8. So that tells us that there is a spring here, so that spring is going to be oscillating on the x-axis. Oscillating just means going back and forth. And when that happens, there's going to be a maximum kinetic energy and a minimum kinetic energy, and a maximum kinetic energy and minimum. Remember, kinetic energy equals 1/2 mv squared. V can be negative, but because it is squared, there can never be a negative kinetic energy. Okay, kinetic energy is scalar. It's only magnitude involved. So that's it. I'll try to splice these two videos together, and let me know if you have any questions. I look forward to seeing how you guys did with this. It's kind of a tricky problem with the calculus, but hopefully not impossible for you. All right, have a good day.